Alright, welcome back. Hope you're all well. Good to see you again. Thanks for joining the channel. Today on the bench, next on the docket, is a Harman Kardon hk300xm. This one's pretty dirty, pretty filthy. It looks like it was stored in somebody's garage for the last 20 years. It's got a layer of grunge on everything. Even came with a tape. I don't know what's on it. Don Williams. Who's Don Williams? Okay, so I don't know the status of this thing or anything at all. I'm just going to plug it in and try it out. Let's see here. Turning it on. Went up to 20 watts. That appears normal, I think. Okay. Play. Fast forward. Absolutely dead on the controls. But we have power. We have lights. We have backlighting for the displays. We have a power lamp, and we're drawing 20 watts. So all that power is going to do something. Looks like we might have something in one of the power supplies, or doesn't even make any attempt to try and work. Okay, so let's take the lid off and have a look. Looks like some cat with dirty paws was walking across the top here. Okay. Wow, look at this thing. This is a beast. We've got sawdust and dirt down here. The motor is spinning. Look at that. I can see the motor spinning. Right here. See that? But we have no function whatsoever, so what is going on here? Looks pretty good, except for right here and right here where all the dust got in and settled. It's all filthy. So I think I might just take this outside. What is this? Are you kidding me? What is that? Why would they do that? And here's another one. They tried gluing it to the back wall. Wow. Okay, so I'm going to get some compressed air on this thing and see if we can get it to clean up a bit, and then figure out why we have no function on our junction. Let's see our power supply here. Putting out some heat. And our motor, capstan's turning. The logic board here just looks dirty. And then we have a big audio board at the back. A lot of switches, a lot going on here, a lot of adjustments. They really put some effort into building these higher end decks, the Harman Kardon ones. I know the lower end ones aren't that great. And they make a 400 too, that's a little higher end than this, so yeah. Let me clean this up. Alright, poking around here, I already found the problem. It's working now. So it's fully functioning. The problem was this switch here. The cassette tape in switch is probably dirty. And I touched it and then it all started coming alive and started working again. See, now it's not working. But if I touch here, it starts. So that's an easy fix. We just need to clean this switch. But then we'll give this a full service as well. It's very filthy and it probably needs it. We got some broken button action going on here. This is typical for these Harman Kardons. I can re-glue that. Yeah, easy. Okay, now that we know it works, let's see how well it works. I got an amp connected, some speakers. So let's try this out here. I'm gonna have to diddle this switch back here. Oh, we got a problem. Yeah, rewind. The tape is going really fast. You can't see it here. I'll show you. Let's take this smoke glass door off so we can see what's going on here, and I'll show you exactly what it's doing. Okay, hopefully you can see that. So when I hit play, look how fast that tape is moving. So obviously the capstan is not engaging. The capstan is not coming up and engaging. Rewind works. Fast forward works. We have the heads are not coming up and no capstan. Now it's stuck. So we've got work to do on this. Yeah. Okay. All right. So I'm trying to decide what direction to take this thing. I think this is a nice deck, and if I can get it all functioning properly, it's going to make some nice recordings. This has HX Dolby, which means headroom extension, and it's got it's capable of metal tape, chromium, ferrochrome. It's got some nice features. 2 microphone inputs with a level control. You got bias fine trim, so you can fine tune it, and then you have your record tones, bias tone, record calibration tones. So this is a really nice option deck, and I don't want to see this go away. Electronic search. Look at that. So, what do I want to do with it? There's a lot going on here inside. A lot of capacitors, and a lot of them probably need to be changed. I'm guessing this thing is mid-80s. I don't know what year this thing was built. Let me see if I can find a date code on something. 1980. All these 3 chips here say 1980. So yeah, this is an late 70s, early 80s deck. Really nicely optioned out. Good thing is, it has a removable bottom, so that makes service easy. So I think what I'm going to do is I want to do a full disassembly and clean. You got full access to all the boards. There's another board under here. This is all biasing. I think I want to give this a full gambit. I'm going to start taking the things apart here, and we're going to work on the mechanism, and we're going to recap, and we're going to see if there's any other problems. Okay, update time. Getting the front panel off is a bit of a bear because you have all these wires that want to stay connected. So these wires are plug into the Syscon board, which is fine. I'm hooked on here. This here is, I don't know what that is. It's a lamp. Oh, the electronic auto search. That lamp unplugs. It's got a plug on it. Okay. This is the pilot light for the cassette deck. It's not on a plug. It's wired directly to the power supply. So you're better off just remove the wires from the power supply instead of fighting with this thing, trying to get it disconnected, because it's glued in place and they're real pain to get to snap back in. So that's out of the way. I can do my cleaning on this. Now, I'm seeing more problems here. There's a belt here missing. This belt is kind of a transfer. This pulley here is a transfer pulley. It transfers rotation to this pulley, which rotates this back here, right? But there's a belt that runs from here to the take-up reel. And if I look inside, I can see the belt laying there. It's probably broken. Let me see if I can dig it out. Yeah, there it is. So that'll be need to be replaced. Another problem is the head block assembly is really, it's sticking. See how it doesn't want to move up and down. It's just like the grease is all dried up, and it doesn't want to move. It should drop on its own, but it's not. So that's going to need to be taken all apart and disassembled and cleaned. Lots of stuff going on here. Okay. So for right now, I'm going to start recapping power supply, and I'm going to see how this goes. You got the green TK caps. I have a feeling some of these are probably garbage already. But depending on how this goes, will depend on how I do on this. If this is all good, I might just leave this alone and run with it for now. But I have a feeling these green TK caps have been never disappointed to be a failure. So let me start on the power supply and I'll let you know what happens. Alright, so I've just finished recapping, and that was a lot of work. There was a lot of caps that went into this thing. And although I didn't find any bad caps, I found a huge percentage of them out of tolerance. Some as far as 35% out of tolerance. So this is a good thing, this recapping. Now, there was no rhyme or reason to what caps they stuffed in what hole. It seems like there's different levels of capacitor here. There's orange Elnas, and then there's a dark purple Elnas, and then there's the green TKs, and I think there was some purple TKs. Yeah, some other TK, and I don't know. So I went through and using the schematic, I followed the audio paths on a lot of these circuits, and wherever there was a capacitor in the audio path, it had an audio grade capacitor installed, or a film cap, one of the two. So all that's done, and the power supply is done. Power supply, and the bias. I think this is like a bias board. And this is all done. This has got a microphone amplifier here, and this is all bias circuitry. That's all done. So I got about halfway through doing all this work, and then I realized, you know what? I probably should have pulled out the mechanics and checked them over, because if there's something dead in the mechanics, that's a deal killer for this whole thing. So I'm going to do that now. I'm going to pull out the tape drive assembly, and we're going to service it. Okay, they didn't make this easy. Now, there's 1, 2, 3 screws on this side to remove. I can remove the top screw easy enough. It's the bottom 2 that are blanked out by that plate. So what I'm going to do is remove this plate, if it'll let me, and I'm going to drill these 2 holes out to allow the screwdriver to go through to reach those screws. That's on this side, and once I drill that, then it'll make it easy to service in the future. But there's also 1, 2, 3, 4 screws on this side, and they're not that easy to get to, I'll tell you. This one here, there's a pulley right in the way. I don't know why they did that. And then there's 2 here I can reach. There's a switch in the way of one of them, and then there's a PCB board in the way of the last one. So I can get these screws out. This should just come out. And then there's also a bottom plate you need to remove. There's 4 screws on this bottom plate. That comes off. And then this mechanism should come out. If it's all disconnected, I'll have to check that too. Alrighty, here it is. Let's tie into this. So we got a few problems I can see, but one thing I like about this is looking at the heads. There's very little wear on these heads. I don't see much at all. This is sand dust head, so it's quite hard, and it won't wear at all. It's a little dirty. You can see it here on the thing here. We got to clean that off because we're going to pull that through the bearing if we don't. So let's get some alcohol. Let's just spin the flywheel. Okay, it's coming off really easy. All right. So what I want to do, I want to remove this cover. It's just aluminum cover. Okay, get this out of the way. Now I was looking at this from behind. I don't know if you can see it on the camera. This playback record head is really out of alignment. It's like crooked. It's at an angle like that. I don't know if you can see that. So somebody's been jerking around with the adjustment here, I'm guessing. Let's see. I don't know. We'll get to that. Okay, first I'm going to get rid of this belt in this motor assembly. So let's get this disassembled. You know what I'm going to do? These bloody wires are a pain. I'm going to remove this and remove this so it's just not in the way. So I'm just going to take off that E-clip. Okay, I'll put the E-clip back on so we don't lose it. I'm supposed to curse on YouTube, but sometimes it's just necessary. Part of the problem is I got a camera in my face and I gotta look around it and then reach around it too. But that's the best place for that clip right now, so I don't lose it. Okay, take this out and out of the way. One more. There we go. And we've got another screw? Yeah, we do. Oh, wow. I'm going to be bending things here if I'm not careful. Okay. Oh boy. Are you kidding me? All these solenoids and everything's all... Okay, let me desolder this. This is ridiculous. Okay, desoldered it. I'll clean it up later. Look at how the belt makes a stain. That's from the belt outgassing. Some kind of a... I don't know what it is, but it's some kind of a brown smoke or something. This motor was really good shape. It's quiet. It just needs a clean. Probably just give it a drop of oil on the bearing and that's all it's going to get. The rest of this is just fine. Leave it alone. Here's our belt. Belt's got good tension. It is not all sloppy and loose and stretchy. This has got a lot of tension still left in it. I think this belt is okay. It just needs a good clean. It's filthy. Let's work on this part here. How come it's locked up? What I want to do is remove that washer. Find a suitable pair of tweezers and take this washer out. There we go. Okay, so I think let's give it a little help down this. There it goes. Where did it fall? I'll find it, don't worry. Okay, so this comes out. Those bearings are perfect, and they are very clean and smooth. Okay, that's flush. Let me look at that washer and then I'll get back to you here. I'm gonna clean up the bench a bit. Yeah, like look at how this stain comes from the belt as it outgasses, and I think it's all easily cleaned up. Let's see how alcohol works on this stuff. Kind of takes it off slowly. A lot of scrubbing though. Let's try a different solvent. Let's try my good old favorite go-to. That works a lot better. It's going to be a little bit of elbow grease. Clean this up. Okay, I can do that off camera. You don't need to watch me doing that. Alright, we got the capstan out and flywheel. Let's remove this plate. Let's remove this plate. And let's reveal what's under it. Okay, we're going to have this come loose. And there's our cover plate. What is this? Where did this come from? This come from here? I think it did. Came from there. I wasn't paying attention. Alright. Oh, I see problems already. Ouch. This, and there should be one on this side too. There it is. Okay. Keep these with the screws. Don't know if you can see. Look at these tires. These tires are split. This one's split. That is going to be a problem. I don't know if I have tires for this thing. Oh boy. Okay. Now our other problem was this thing going up and down was really stiff. Okay, this part's not stiff. This part is. So what is holding this? This bearing here. I think they just need to be re-lubricated. And they're really not. They're just held in with a screw. And then there's a ball bearing here. To hold the plate down. Keep it in alignment. Otherwise the plate, if the plate's flopping around like this, then it screws up the alignment of the tape in the head. And here's the other side. This is all good. Solenoid. I don't know if this solenoid was working because I don't remember it clicking in. So maybe I might want to put power to this and see if it clicks in. And this other solenoid too. Check both of these. They're free mechanically, but we don't know if they work electrically. And oops, I'm losing our tire. Tires in like little pieces. Let me see what I got for tires, because if this, I don't have any tires, then this is the end of this. And there's a belt in here too. Look at that. Okay, so we might have to take that motor out from this side. Let's do that right now. Wow, it is tight. Okay. So where is our... I might have to desolder these two. Or should I just remove it? Let's remove it. We're going to clean those switches anyway. Okay, what do we got here? I'm going to remove these two wires, this green and orange. And then we need to service these two switches. Okay, bad news. I only have tires that are quite large. These are all intended for VCRs. So these ones, incredibly, they're too large. The smallest one I got is still too large to fit. This one, it might work. Might work in that position. This one needs to be replaced too, because it is split. You can see it's split in two spots, there and there, and I can actually probably just take that piece of pie out of the, see how dried up and cracked it is. So this is going to get put on hold for a few weeks until I can get tires in. I'm going to measure these up and see if I can figure out what size they are. And I know this one's really weird. This one here is really, it's a small flat tire. It's really thin. That one's going to be the hardest one to replace. This one here, not so much. But I'm going to get an order in, see if I can get some tires. Get a variety of tires here, see if any of them will fit and work. See, like this one here is close, but it's not good enough. Which one? Between these two, I think this one might be the best choice. That one might be a good choice for that. Let's see if it fits on the pulley. Yeah, it's pretty sloppy. It's a little big width-wise, and yeah, it's got too large of a diameter, because the tire will, if it's required to transfer any torque, it'll do stuff like this. It'll ball up on one side. Not good. I have to find tires. So this will all get packed up and put on hold for a couple weeks until the tires arrive, and then we'll have to come back and revisit this. Okay, so it looks like I can find some sizes that are close. I got 8mm by 1.5 by 1.5, and I think I can use two of those together on the small pulley. And this one here, this one here, 2.1 by 1.9 millimeters. That will work on the large pulley. It's very close to the original size. But you can get lots of different sizes here. You just got to measure them up and see what you need. Quality, who cares? You know, it's a rubber ring, right? You know, it's going to last you another 20, 30 years. So just get over it, and yeah. So I'm going to order these, and they should be here probably a couple weeks, and we'll see how they fit. Another option is you can buy one of these variety packs, and they have all different sizes, but the thing with this is you don't know if it's going to have the size you need, and so you know that would be good to buy if you're to have on hand as stock in case you run across a machine that you need to fix. But just for this purpose, I don't think it's going to work. Alright, so here's the main capstan belt. Just to measure it. This might help somebody if they need one. So that's an 8.5. Okay. And what do we have for width on this? Looks like a 3 mil. Yeah, 3.5 mil or 3 mil. That'll work. And what about this belt here? Let's see. This one, it's still holding up. I would still run with that. This is a smaller one. Let's see here. This is about a 3.75, 3.6, 3.75, and same width. Looks like a 3 mil, 3.5 mil. So what I'm going to do is probably I'll end up boiling these two belts and running with them again because they're still good. What about this belt here? This belt is, let's see if we can get it off. This belt here is bad. This belt is going to break. I don't know if you can see it. Let's try here. Can you see? When I pull on it, see how it's got the cracks open up? I don't know if the camera's picking that up. Right there. See when I pull on it? Cracks open up. I don't know if you can see that. But anyways, it is what size? Let's replace this belt. This one is about a 4.6, 4.5, 4.6. And it's a thin belt. 1 millimeter. What is this? 0.8 millimeters. It's got to be a thin belt because it's really low torque and it has to have really low rolling resistance. Okay, I'll get a belt for this, replace that, running with these two after I boil them and clean them. And then I got tires on order. I'm still missing a belt here. It's the one that broke. And if you pull on it, you can probably see cracks opening up. Anyways, let's see what we got here for length. So it's about a 6.5. 6.5 would work. And it's got to be a thin belt too, so I'll replace those two. Okay, while we're waiting for parts to come in, let's do the rest of the service on this thing. We have to lubricate the take-up and supply reel, and it's pretty simple. I don't know if you can see that. You push it down. You can see that little washer there. You got to remove that washer, and that releases the reel. So we can take this off. Try not to mangle it because we're going to reuse it. So we got it here, see? So put it someplace safe. Don't lose that. And we can take off this. There's a little felt washer here. I don't know why they got a little felt washer. But let's clean this shaft. It looks like they're running dry with this. Let's clean it with some alcohol, and then we'll lubricate it with some grease. Okay, we'll reuse the smallest amount of grease, just a very small amount like that. You can see that little blob on the end there. That's all I'm going to use. Just going to put a little bit and then spread it around. Okay. Put our thing back on. Let's clean this. The surface where the brakes are applied on. Okay. Pull the brakes back. Good. Put our locking washer back on. You gotta be kidding me. Where did it fall? Okay, right here. Let's try that again. Push it on. There it is. Okay. Other side. Very good. Now this side has a optical disc. Really? So it's an optical disc. It's painted black and it's got 3 white silver stripes on it, right? And it gets glued into here where the glue has failed. So we'll put that back together with some glue. The purpose of that is right here there's an optical sensor. There's one side has an LED, the other side has a phototransistor. And what it's looking for is reflected light. So when it sees this thing turning, it's going to get a little blip of light every third of a revolution. And they're not even evenly spaced. You'd think they'd be 120 degrees apart, but they're not. So every time this rotates and goes by that little sensor, you get a little blip of current signal, blip, 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 and it tells the microcontroller that the reel is turning. That's the sensors. And when this stops turning, it does an auto shut off. That's the end of the tape, auto shut off. So that's what that's all about. This side has a plastic washer. Looks like a plastic washer. I can't raise it. It is there. I can see it. I can spin it. So let's clean this shaft and give this lubrication. And let's clean the outside of this. And let's figure out what we're going to glue this back together with. We don't need anything fancy. What can we use? This glue breaks down and then it just turns to dust. See, it's all coming off. I should clean the old glue off first, I guess. And clean all this old glue off because it's not going to bond. The new glue is not going to bond to it, so I'll just remove it. There. Clean all that crap out of there. Where's my disc? Don't bend this, it's just aluminum. If you bend it, you're going to have a hard time getting it flat again. Just going to scratch this up and roughen it so the glue has something to stick to. Okay. I really don't keep a lot of glues here, or adhesives, but this stuff here, this is a craft glue. And it says solvent based, so I think if I smear some of this in here, just get a very small amount of it. Oh, that's way too much. Okay, let me spread this around. Avoid getting it in the center. Oh, this is not going to work, I don't think. Okay. I was thinking of using silicone. Let's try this. All it's got to do is hold that little aluminum disc in place so it doesn't slip or fall around. Okay. See if this holds. Get rid of the excess. Clean this up. Okay, I'll see how this holds when it dries. Probably be fine. So we got to discover why this mechanism is so sticky. It's greased up here, it's greased 2 spots here, and there's grease here, and there's a ball bearing that has grease here. I expect there's some slides underneath too. Yeah, I can see, oh, maybe not. See, this spring should push it back up, or pull it back down, but it's not. I think we got to disassemble all this and clean it. So I think what I'm going to do is I'm going to remove the cassette tray, and so that opens this all up, and we can get in and actually service the slide mechanism. Where's my good screwdriver? Let's remove this because it's just in the way right now. Remove this whole thing. I can't get to that screw. What kind of a construction thing is this? Do I got to take this apart? Let's take this out. There's half of it out. Oops. And the spring wants to unload. Okay, leave that. One thing I can do is just remove this E-clip, and then the door would come off. Come on, baby. There we go. But there's a spring here too, you got to remember. Okay. Now we got full access. I'm just going to zip tie this spring here. I don't want to lose it. Okay. Yeah, it'll stay there. First thing I want to check is this. Some kind of a spring. Here's our ball bearing. We don't want to lose that. So let's re-grease all this. Let's do that after we do this. Ooh, you're tight. So what do we got here? We got like a little brass washer. Okay. Yeah, this grease is very... Yeah, that's not going to come clean. I think what I'm going to do is I'm going to disassemble this altogether. Let's take these out. Wow. There. Okay. Take the spring off. Okay, and then take this one. Okay, let's clean up all this old grease. I think this is the problem, to tell you the truth. Get rid of all this old grease. Some kind of a graphite grease. All I'm doing is spreading it around. Okay. I think I got to remove the pinch roller too. Yeah, I think the pinch roller's got to come off. Stiff. Look at this, is all stiff too. Grease on this is just completely dried up. We'll do that as well. Put this back on. Okay, now we can get in and clean this properly. Okay, looking better. Okay. Rid of the fuzz. All right. I think we've got this. These pieces here for the capstan are all gummed up. This could be part of the reason why I was sluggish and sticky, is because these don't move when I move at all. Look at that. It's all dried up grease. But we're going to make it better. Okay, get rid of that. Whatever grease they used, but it didn't stand the test of time. How's this thing doing? Doing fine, it's just dirty. Okay, we'll clean that. Okay, that's clean, that's clean. All right. Okay, we got some here. Get this grease here, this off. This will clean the heads while we're here. Not very bad. Okay, now I need to figure out a way to clean these little things, these little brass. I'm going to clean that old grease out. I think I'm just going to soak them in contact cleaner. Get a little cup, put them in. I got 3 of them. And I can give them a soak. Where's the third one? Here it is. I'll give them a soak, and we'll wash these up, and then we can put it all back together. So I got a little container here, just put these in. Don't need a screw. Just need the washers, the bushings. And give it a little bit of juice. Yeah, this will work. Let's see the one. Okay, I think we're done. It's been in there for a few minutes, been shaking it. Let's see what we got. A little bit dirty still, but we can clean that up. I might give him another bath here in a second. Just want to make in the groove there's still grease. Yeah, still grease. Yeah, I think I'll just put them in and let them soak for a bit longer. Okay, so it's the next day. Let's see here, where is it? This here. I put this and let this sit overnight and let it soak. So let's see how it cleaned it. Just had that nasty graphite grease on there. I think it's going to be good. Okay, so I'll just dry these off and we'll use these for assembly. And we'll use fresh grease, of course. Let's dry these off. But first, I want to check this. I want to see how this glue is holding. It's going to tug on it. Yeah, that's good. So we can do this. We can put this together. So let's... Where's my grease? Very small amount of grease. Let's put this on. The washer's there. Perfect. Now where's my locking? I actually lost this and I couldn't find it, and then I found it on the floor after looking, which was kind of surprising because I don't think I remember taking it off the bench. There's a trick for finding things on the floor. If you get a strong flashlight like this and you put it on the ground, and then you shine it like this. Anything that's small will pop up and be eliminated. It's a trick I use if you're finding stuff on the floor. You just get a flashlight and just a real bright one and just shine it on the floor like this, and then you'll see it pop right out. I don't know if any of you guys knew that, but I do it all the time. Okay, that's good. That's good. Let's move on to this. So what we need to do is clean these a little better. And try and get the grease out of that groove. It's going to be okay, I think. Put one there. Okay, put one here. And we need to put one here. Okay. I got this totally wrong here. Okay, gotta go over this way. Yes, now it makes sense. Okay, I'll put this one back. Alright, so what we need is this to get locked in here. No? That slides really easy. What's it riding on? Ah, I see. How did that get there? That's spring. Okay. Spring was caught. And it's still caught. There we go. Yeah, the spring got sandwiched in between the two plates. Just gotta make sure it's sitting down on all of the bushings. Let's put this one in first. Let's take this out. Take this out. And let's do this. Okay. Can get my finger in there. The solenoid's in the way. Okay. I'll torque them all down later. Just going to connect the spring. Okay. Look at that. Now we need this. What screw is missing? Here it is. Okay. Okay. That's the way it should operate. It should come down by spring pressure, not... Okay, so let's grease up our slides. I'm just going to inject grease in here. Oops, too much. Okay. Do the same on these two. Okay. Perfect. It's even better now. And I need some grease here. Okay. Now we can deal with this. Little ball bearing and some old grease. Where'd the ball bearing go? Okay. Does this washer go here? Maybe. That feels like the wrong thread. Okay, that was my screw up. I was using the wrong position here. It should actually go like this. Onto here. And then we get a screw. Don't know if it was one of these. Let me try this one. Yeah, that's the right screw, and that is the right position. Let's tighten that down. Perfect. Perfect operation. That's the way it should be. Now we can pretty much, we're finished except for, where are we? Where's my parts? We can assemble everything except for this because we're waiting on tires, right? So we can do all the servicing of the motors and cleaning. And actually I'll take this apart and maybe it needs lube. Probably does. So put everything back together except for that reel motor. And I'm glad this is fixed. Let's see here. Yeah. Okay. Okay, let's torque these down. Okay. Next up, I think could probably put the flywheel back in. Just thinking here. Okay, put the flywheel back in. So I'm going to grease the shaft probably about halfway down. And we'll get this in. Where did our washer go? Let me find that washer. I just put it down somewhere on the table here and now it's gone. It's transparent, that's why. There it is. So this will lock the capstan in place. Okay. That's perfect. Let's put our capstan back together. Let's see here. I'm just going to add a touch of grease to this shaft. Okay. Clean the pinch roller and then we're going to put it on. Okay, pinch roller. I greased the shaft and I cleaned the rubber surface with rubber renew. Oh, you can see it looks a lot better. Probably could have cleaned it more, but I think it's good enough. What do we do with this? We need to figure out how this goes back together. So that obviously goes on like this. And this, I think, goes on first. Like that. What does this thing do? It gets caught in there, okay. Okay, so that goes on first. This goes on second. Let's lubricate everything. Okay. This goes on first, this goes on second. Like that. And then this spring gets connected. So let's connect the spring. Put this back together. I think it goes like that. Okay. So this one goes first. First, come on, you can do it. second, third, fourth. Okay. But it has to lock in down below. So let's, there we go. E-clip. That's not right, the right E-clip. Where did this E-clip come from? The smaller one. Here. There we go. That's the way it should work. So when it comes up, pinch roller contacts the capstan, and then when it makes its last few millimeter travel, then we're under spring tension, right? This thing should be under spring tension. That's what the spring's for. So that's correct. Looking good. Okay, we can put, what can we do now? We can clean these, that's not the switches. We could probably put our cassette, we could probably put our cassette door back in. How does this spring go? Oh, that wants to pop off. Let's put that E-clip on there. Let's give it a little bit of juice. Squirt of juice here. And then we'll put our E-clip on, and that will stay on for us. Okay. There we go. Now we can concentrate on the other side. Spring goes down against the plate, I think. A couple screws here. Put one in just to hold it. I don't know if this spring is incorrect. It must be. It wouldn't work otherwise. Well, that's how it's staying. It's working. Okay, put the other screw in. Let's put our dampening in. This piece goes through here. Oh, and that goes on the cover. Okay, we got to put our cover in place. And this keeps wanting to fall out. Let's do this. Let's service our motor first. I'll clean the face of the pulley. It's kind of dirty, and then I'll give it a drop of oil. I wish I had a needle on this can. No, that's not going to work. And what I'll do is I'll put it on here. Don't need so much. Okay. There, perfect. Let that absorb in. Let's clean this. Okay, good. Now I need to service. I'm going to go boil these belts, and then I'll be back. I'll clean them up, and then we'll reuse them. Alright, let's see what we can get off this belt. Some alcohol. The water came out kind of cloudy. You see, it's still dirty. Oh yeah, look at that. Lots of crap still on there. So the belt boiling doesn't do any cleaning, it just actually, I don't know what it does for the rubber. It must kind of do something. The cleaning itself is a different matter. I'm going to use alcohol and go aggressive. Tug, tug, tug. Just keep doing this until this black stuff stops coming off. See, we still get black stuff. Another thing you can do is turn the belt inside out and run with the other surface. This surface might be, yeah, I think I'm going to do that. All right, let's put this on. Now, how did this go again? It went like this, didn't it? Let's get some screws in to hold this. Ooh, I forgot something. Let's put one in for now, and this will hold it together until I need to do the final assembly. And the belt is working good. Okay. Now we can do our damper. We can put this in. This goes here. So let's put this. Let's put a screw in here. Alright, now we can connect up our door. Good. Now, once you put the weight of a cassette and the front door glass on here, it's going to open a lot quicker. Now, it's just going really slow because it doesn't really have any weight on it. But I think everything's good. I think we can tighten all these screws down. And we can call that part done. Okay. Now, the shield, I could probably put that on too. I think we're done. We're done with this. I put this on. Put this on. Let's put another screw in here. I'm going to loosen these off a bit because I don't think that will go in. I think this one here. Okay. These are tape heads. This is motor. Switches. Let's clean these switches. So these two switches detect a tape inserted. One of them detects a tape inserted. I'm not sure which one. And the other one detects the... I thought there would be more. One would have to detect the erase tab, and the other one would detect chromium dioxide. But where is the tape sensor? There's only two switches. And it looks like they're difficult to clean because the contacts are buried down inside. So the best thing for these would be replacement, but where do you find them? Let me think about how I'm going to clean this. Alright, so for these switches, there's really no way. Oh, hang on. I can take this cover off. Let me try that. I thought there was no way in, but it does have a cover. Let's try prying this cover up. But it might break the switch. Yeah, it's riveted here. Yeah, I don't want to upset that. So, yeah, there's only one way. There's only two things you can do: replace the switch or clean it. So what I got here is I got a thin sliver of 3000 grit sandpaper, and this is the grit side here. I'm just going to put it down inside where the contacts are, and then get the contacts to close, and then just work the sandpaper back and forth to lightly take away the oxide layer. I'll flip it over and do the same thing on the other contact. This seems to be effective. Open these contacts up by clicking it and then shove it in. If I can get it. It's very tight. Okay. Just going to clean it like that, and then do all four surfaces. These switches don't use both sets of contacts. One's normally open, one's normally closed. Okay. Now let's do a test as to contact resistance. So let's see what I got here now. Got 13 milliohms. Let's do the other side. Open. 16 milliohms. 15. That's going to be good enough, I think. Let's try this one. See, this is reading in the hundreds of milliohms, so we gotta treat this one. Let's cut this off. Expose some fresh sandpaper. Okay. Flip it over. Now, I don't know if you can replace these. I'd have to look where to get these switches. Doesn't want to cooperate. Get in there, damn it. There we go. Okay, let's test it again. $13 milliohms. Oh, it's going up to 45, 75. Okay, we're gonna have to do more on that side. Let's try this side. 25 milliohms. 18. And I'm going to do some more work on these switches. I'm going to get them till they're both consistent and they're both down low enough that I'm happy, and then we can reinstall it back on the board. Just solder them back on. I replaced this cap. This is a bipolar cap. It has to be bipolar because the reason is it's across the motor, and they use reverse polarity to get the motor to spin backwards. So they put one polarity in to get the motor to spin for the take-up reel, and then when they spin it the other way, it goes over to the supply reel. So that's your fast forward or rewind, and this motor is bidirectional. Everything else looks good. I got the belts on for the type counter, and I was just testing it here. It seems working. See if belts are transferring what they need to do. Everything's good. I'm not going to put the plate back on here until after we reassemble the supply take-up reel motor. Everything's back together, and for right now I'm going to put this on mothballs because we're waiting on the tires, and when the tires come in I'll revisit this and complete it. So you won't see any delay, but I'll see about 2 weeks, and I'm just going to pack this all away and make sure I don't lose anything, and then we'll free up the bench to work on something else. Alright, so my tires have arrived, and I bought I bought a whole bunch just to cover my bases, and I wanted to have some extras for the parts drawer. So this is a pack of 20, but somehow only 19 made it to me, which isn't a big deal. This thing cost me like about $4, and this is a good deal because $4 shipped to your door. That's Canadian. Probably get it for $3 in the States, and it's got a variety of sizes, different sizes you might come across. So that's something good to have on hand. But these ones here, these few here cost me $25 almost. Actually, over $25 to get them here. These are they're about $2.30 a piece plus shipping, so that's why it's so much. And I ordered 2 for 8 of them, so eight tires, $25. It's not really a great deal, but I needed the specific sizes, like these ones here. These are the 8mm by 1.5 by 1.5, and I think this is the one I need for this small pulley here. So let's try these out. I think it's going to work. So let's put this one on. Now I got the narrow ones because I can fit 2 on here. So let's try this. Come on. Might not want to go on. There we go. Okay, there's one tire. Let's put another one on. I knew I was going to have to go wide with, they don't make a 3mm wide tire in this diameter, so that's why I bought these narrower ones that will, I should be able to squeak 2 tires on here, no problem. Okay, get this one to lay. There we go. Yeah, 2 tires will work. Okay, now I need to decide about this one here. This one is, let's see, let's go millimeters. What do we have for diameter? We got 9.5, and I ordered some 9mm. What's our width? 2mm wide. So I got 9. $9mm by 1.9mm. That's the closest I could find, and I think it's 2 of these, so it must be one of these. And it looks like it's probably too thick. We can get this on. Get it to lay properly. There we go. Yeah, it might be too much. Look at how that's bending. See how that's bending? I'm going to have to find a smaller thickness one for here, because that's just too much pressure. That'll snap. Let me take this one off. See, when I take it off, it's relieved and it stops bending. Okay, let me figure out a different tire for that pulley. So yeah, these ones are too thick. Why do I have two different sizes here? These are different sizes. Anyways, I think the best one for this is the 9 by 1.5 by 1.5 millimeter, which is this one. I think this is going to be a little better. Not so much pressure between the two rollers. There, that's a lot better. You can see it's not bent. It's going to transfer the torque just fine. All right. This thing has to go here, I think. I wonder if that goes down. There we go. All right. Secure that down. Perfect. Okay, get some screws. Where are all my screws in this bag? I'm going to dig through this and get everything ready. This thing, I'm going to put it on, but it's filthy. It's got smudges and grub all over it. Okay, I think that looks good. It's got a little bend here. All right, let's secure this down. Need my hardware. And that should do it. Okay. Can't see anything. Let me try turning this. All right. Okay, that'll hold that. Now we got to put this piece inside here. Some kind of shield or something. So let's put this do it with it closed. I have to do it open. Come on. This is finicky stuff. Okay. All right, that can go back into the machine, into the deck. I think I pretty much finished everything. Our belts are connected. If I turn this, this is working. That's all good. Everything is back to where it should be. Okay. I'll put this back in the machine and then we'll get it connected and see how it runs. Okay, we're back together enough that I can test this. You notice the two buttons are missing. I actually broke them when I was putting the faceplate back on. These are so flimsy. It's just a little tiny piece of plastic sticking out of here and it just snapped. So and then one button of this flew across the room and I can't find it now, so I have to salvage one of these buttons off another receiver or something. I'll have to find it, I guess. Dig through my garbage here. But anyways, let's turn this on and try it out. I have a feeling it's going to be working now. I have no audio connected, but let's try. Here, it's working. Our heads are up. It's going the correct speed. We're getting signal on both channels. Okay, very good. Now, one thing I want to do is go through and check switches in pots because I don't know how... I didn't touch any of these switches or pots. And I think... Let's try this. Fast forward. Rewind. Play. I think our mechanism is good now. So yeah, I didn't check any of these pots or switches. So I want to go through and do that now while I can before I put too much of it together. And then I'm going to find that button, do the final assembly, and then we can move on to alignment and adjustments. So this seems pretty good deck. It's working now. Alright, it's the next day, and thankfully I took a few hours and searched the room, and I did find the other button. It flew across the room and it landed in a bucket of scrapped cell phones. So these are kind of unique because they're quite thin, and if you go to the Harman receivers of the same line, they use the same buttons, but they're a lot thicker. They're probably another millimeter thicker. These ones are quite thin, and they're difficult to replace. So my standard fix for these is drill them and glue them with a support screw. I don't know if I showed this on other videos. I'm not going to do it here. I've shown it on many other videos where I fixed the Harman Kardon's buttons, and I drill a small hole. Well, first what I do is I select a screw, something that's small enough thread that will work on this here, like that. And I'll drill an appropriately sized hole so that the threads will bite into the plastic. Now if this screw's 10 millimeters long, I'll drill 5 millimeters in here, 5 millimeters in here, and then I cut the head off the screw, obviously, because that's useless to me. And then I use the threaded shaft as a repair for... It goes halfway into this, halfway into that, and then I back it all up with two-part epoxy. And that works really well. I've done a lot of these repairs. I've shown it on past videos. I'm not going to do it today. I actually fixed this power button using the same method. And you can see it's secure. It's not wobbly. And if it takes a... These buttons are pretty good if they're used normally, but if they take a side hit, it'll snap that joint. And... but hopefully we're not going to do that. So I'm going to get busy fixing these two, and then I can get it back into the machine because that looks terrible, and we'll get this back in order. something like this. See, look at how terrible the connection is. Just a little wimpy piece of plastic just snaps. And it's very fragile. And this plastic gets brittle with age. And yeah. See that little piece that's in there? That's wedged in there and glued. And it's just a tiny, tiny little thing of plastic. Same with this one. And you can see where it snaps. Doesn't take much to snap these. Side pressure, it's very, very fragile. And so yeah, I broke 2 of these. And usually you can tell when they're broken when the button starts flopping all over the place. These ones are okay. These ones are okay. So I'll get busy on that, and then I'll get back on track with the alignment. Okay, so I'm all wired in to do a test. I got an amplifier hooked up. I got a tone source connected to the input. I just want to make sure our controls are clean and switches are working. And if everything else is fine, we'll shift our attention to doing the alignments. So let's see, I got a tape in. This is the first time we can play it. I want to hear a heartbeat. Okay, he wants to hear a heartbeat. Let's see. That's Don Williams, I guess. Let's see what's on the other side if we have any blank space here. String 5, 6, and 7. We'll be right at 7. Got really low levels here. Okay, let's see. Okay, you know what? I don't care about this tape, so what I'm going to do is I'm just going to flip it over, and we'll use that for our test. Let's rewind it to the beginning. Okay. So let's put this in pause. How does this work? Stop. Record, pause. There we go. There's our tone. Yeah, a little bit scratchy. Quite a level difference here. Okay, so I gotta treat that pot, left channel. This one's okay. The pot's a little scratchy. Low noise, noise reduction on. Yeah, we got about a 3 or 4 dB difference between both channels. Okay. Let's do some recording here. Turn this down. Just making an awful noise. Making a whistling noise. It's the cassette. Okay, everything's working as it should. So what I'm going to do right now is we're going to tackle the tape speed, and then we'll tackle the alignment of the azimuth, and then we'll tackle the balance of all of the amplifiers. So let's see what we can do here. So for speed adjustment, there's an opening on the back of the motor, and there's a hole on the syscon board to fit a screwdriver through. Now, as playing with this, if you drive the screwdriver in too deep, you're going to touch some rotating parts inside. That's why I'm using a ceramic screwdriver. It's not it's insulated, and you can't short anything out. You don't want to use a metal screwdriver here, I don't think. So what is my frequency right now? Let's have a look at the counter. So there's the counter going, and let's turn on the tone tape. And we're about 18 hertz fast, which is very close to being, let me try rotating this a bit. A little too much. You're not going to get it perfect, but you're going to get it fairly close. .3000 hertz. Keep touching the motor. Okay, I'm going to leave it at that. That's good. So I'm done. Okay, so for the rest of the alignment procedures, there's quite a bit of information going on here. There's a lot of adjustments and so on. And they also reference TAC test tapes. A TX MTT316, a TX MTT 111, a TX MTT 150, so MTT 114. I don't have all these test tapes, and I don't know anybody that would, other than factory service. But I'm going to go trudge my way through this and see if I can make any heads or tails of it, and see if I can make any adjustments that it needs. Quite a bit of this probably is already an adjustment, but you know, with all the new caps and everything, we have a little bit of level discrepancy on the inputs. We're going to go through and make sure everything's good. I'm not going to follow along with a camera because this would get really long, boring, and tedious video to watch, and it's just going to take me probably all afternoon to work my way through this. Like I said, we already did the tape speed. That was the main one. And the next one we're going to do is the head azimuth, and I'll do that off camera as well. I do have a test tape that I've made up, and it's probably as best as I'll get. It's probably on par with commercial tapes, but I won't know that until I start working on this. But we're going to get this cleaned up, and then I'll bring you back in and we'll do some demos. Okay, here's a 7 kilohertz playback tone, and you can see the left channel's working good. Right channel's having problems. And here, I'll show you. There's 2 relays here I haven't serviced yet. This one here, this big one, and then there's one behind this little metal can shield. You can't really see it, it's there. But watch what happens when I tap this one here on the first one. Okay, here we go. You see the amplitude comes up and down. So we definitely have dirty contacts on those relays. So I'm going to take the relay apart and clean it. Alright, so I got this weird relay removed, and it's like a solenoid with some contacts on the bottom. I did check contact resistance on a couple things here, and it looks like it's high resistance. And this is something weird, 22 volts. It's a stereo relay. So let's try opening this, take the cover off anyways, and see what we're up against. I've never opened one of these before, so I don't know what to expect. Just have to be careful with these. Let's get this open. I'm pretty sure this is the cause of our problems. Okay, I think, yeah, I got a blob of solder here. Let's try pulling this apart without wrecking everything. Okay, so these two here are the coil pins, and they want to stay behind, so I'm going to clean those off because they don't want to go through the hole. Very good. I'm going to clean this off. If there's any solder. See if that goes through. There we go. Awesome. Okay. There's our switch. Now we got to remove another cover. Let's remove this cover. See if this one will come off now. And it will. Perfect. And there's our dirty contacts. Everything's pretty oxidized black. So let's polish these up. Get our contact resistance back to normal. And then we'll treat this. You can see the oxidation on those contacts. Alright, I'll just get some polish and we'll get that cleaned up. For this I'm using silver polish. And this is literally how much I use. Probably about that much. I already see a big difference. Okay, that's all you need. I'll do this one a little bit more. It's right in the end here. These end ones are okay. Give it a buff. So that's what it should look like. So I'll drop this in the ultrasonic cleaner and get rid of all the residue, polish, and other junk. Give that about 10 minutes in some just plain water, ultrasonic, and then we'll come reassemble this. Okay, it's out of the ultrasonic, and I use compressed air to clean it and dry it. So let's put this back together. We have 4 of these springs, contacts. Can't do this with my big fat fingers. Okay. Now we're going to treat it with some deoxit. We're going to use the concentrated 100, D100. You want this on both sides. Very small amount, just to wet the contacts. Okay, This is the tricky part, how to line this all back up so it Alright, we're pretty much done. Now I need a screwdriver to spread these. Just going to spread them a little bit. This is probably the reason they use this relay is because it's shielded. It has this metal shield. Keep noise down. Need a better screwdriver. Alright, let's see what we can do here. Okay. It's not coming off. It's loose, but it's not coming off. And we can put this back together. Make sure this engages with this. And we have to get our pins back in the hole. Spring action is good. Okay, I'll close that up better. Get rid of the lint. I'll close this up and then we'll reinstall it. Okay, relay's soldered back in. We're ready to go. Let's test it again. So let's go back up on the scope. So this is a 7 kilohertz test tone. Looks like we got both our channels. Let's turn it down a bit. Right channel looks a lot stronger than it was before. It looks a lot cleaner too. So the relay clean was a good thing. So let's try adjusting azimuth. See if we can do this. Okay, that's the wrong way, turning it back, going down. So right at about this point here, I'm getting the best amplitude and phase relationship. If I go too far one way, the phase shifts. If I got to bring it in the center. I wonder if that's the pinch roller doing that. Every time it makes a rotation, it seems to shift the phase. Let me try a 10 kilohertz. 10 kilohertz tone. Yeah, I think that's what that is. Try adjusting this a bit. get it. Phase shift on that right channel. Well, the scope is locked to the left channel. That's why it's stable and it looks stable. That's because it's triggering on the top trace. But the bottom trace is running free, and it shows the relationship of phase between the top and bottom. That might be a pinch roller. Because it seems the frequency of that seems to coincide with the frequency of how fast that pinch roller is rotating. Okay, I think I discovered another problem. We have no record on the left channel. Right channel's recording, playing back on both channels, but no record on the left. Now, I did clean this knob, so that's not the problem. I got a scope connected to the head terminals. Let's have a look at. Okay, what I'm going to do is I'm going to set it up for record, and our left channel is the top, or sorry, right channel is the top. No, left channel is the top. Right channel is not showing anything. And there's our bias. This is the bias trim I'm playing with. Here's the bias equalization settings for metal, chromium, ferrochrome, normal. So that's all working. Bias tones. Nothing's coming through on that one head. I'm going to have to resort to the schematic and see why we don't have any tone on that one head. Okay, I think I just found my problem. I was going through and doing this record playback level adjustment, this one here, this part of the adjustment procedure, and you connect a signal generator and you tap off of test point 1 and 2, you pick your signal off, and then you make test recordings with a 400 Hz signal. And the problem I'm having is one channel wasn't recording audio. And then I started doing some more recordings, and I found out it was actually recording audio, but it was such a low volume that you couldn't hear it. And the adjustment here laid out says I need to adjust VR 301 and 302 for left and right. And then you record a tone, you play it back and listen to it and see if it's proper level. And you keep doing that over and over again. And then you go through the other positions from metal, you go to low noise, ferrochrome, and chromium dioxide. VR 301 and 302 are these two calibration holes. There's a little potentiometer behind you, you adjust with the screwdriver. Now I was able to adjust the right channel, no problem, get that, but no adjustment from the left. Now what's going on here? And I found the problem. And the problem is a broken connection between the potentiometer and the board. So let me show you here. Here's my continuity meter. Now this green cable here comes down and it goes across, and under here, you can't see it, but it goes to the board where the little potentiometer is. So now if I check the pink wire, I got continuity. If I check the shield or the center conductor, I got continuity. If I check the white wire, I have absolutely nothing. That white wire is broken. This white wire here. So I'll have to figure what's wrong with this cable. Either replace it or get something else in there. But that's my problem. So as soon as I fix that, I should be back on track and we can finish with the adjustments. So I tested up to the wire. I have continuity on the wire, but not on the solder pad, so it's just probably a bad solder joint. So let's re-solder this. If I can get in close enough to see what I'm doing here. There, that should do it. Looks clean now. Let's test it. And yeah, that's working now. And the other one, this is the center conductor. that's working. And then the pink wire. Pink wire's back here. Touch this trace. It's all working. So now I should have my left channel record back. Okay, I just finished making the video for the test video, and I'm really pleased with how this deck turned out. I'm going to finish cleaning this up and put it back together. I think I might still have a couple more adjustments to do. Spent pretty much the whole day adjusting it. Wanted to get it right, and I think I kind of got close. If you listen to the test video, it's a little more brilliant than the original, mainly because I think I had the bias trim a little too high, but I should have turned that down about halfway, and that would have been a perfect recording, or close to it. Yeah, it's a nice machine. I'm really impressed. It works really well now. Had a lot of problems. Belts, tires were mainly the main problem. Sticky grease, and that prevented it from working. I don't know how long it sat like that, maybe 20 years, who knows. But we got it sorted now. All new caps, that was necessary. A lot of these TK ones were dead. It's just better to go through and replace all these, because they won't be anywhere close to what their value should be. And the ESR is all over the place too. So get fresh caps in, and I think it worked really well. A lot of the caps in the signal path, well, are either film or audio grade. So everything else, I used a lot of solid poly caps in this one, just for power supply. I did a lot of bypassing of the filter capacitors with smaller ceramic caps too, just to clean up the power supplies, and I think it turned out well. So, alright, that's it for this one. Thanks for watching. Take care, and we'll see you in the next one. Lots of stuff coming up, so stay tuned.